Okay, greetings. So who doesn't like a good game of Tetris? Well, I assume there are some people that really don't. Honestly, sometimes my life feels like Tetris. Just too many pieces I got to process all at the same time. And I think game over happens quite a bit for me. But anyway, in this example, if you're familiar with Tetris, we're just going to go and liken some of the elements of a Tetris game to what's happening today in modern data architecture. And a lot of that has to do with big data. A lot of that has to do with semi-structured, NoSQL, lake type deployments. But let's go take a look and see what we're talking about. So first of all, well, Tetris, it's fun, it's exciting, but it also gets a bit hairy sometimes when the pieces keep accelerating and you can't quite keep up. Still, again, fun stuff to do. Tetris requires quick assessment, really, of what the thing is, categorization, turn it, put it where it belongs, whatever it is. It's a very quick moving game, as you know, if you've played it. And by the way, if you haven't, you should go back and play it again. I think it's on every platform you can get on to play this game. To succeed, you really got to move these things really quickly. But what helps us is that there's a known set of possible shapes. They have consistent colors to reflect them, and they just arrive on the screen one at a time, so we can kind of deal with them as they go. But let's take a look about some of the fundamentals on today's modern architectures. Today we have big data and lake deployments, and there's a lot of different ways to define these things, but if we go into kind of the original big data 3 Vs that became 4 Vs that became 5, now that maybe there's 7, but whatever they are, volume, huge volumes of data, velocity, they're going to hit you real fast, maybe even streaming type deployments. Variety, they're multi-structured, could be changing, shape-shifting structures. And of course, veracity is an issue, meaning what's the quality, what's the accuracy and reliability of that data. And of course, there's varying levels. And then lastly, on this 5V version is, well, business value. What's the value of having this data coming in? So now, back to the Tetris game. It is fun and exciting, the pieces start accelerating, and that's great. But if we look at it a little bit further, what if you could not see the form or the color of the shape that was coming down on the screen? What if you weren't able to see what shape it was or what color it was? Then what would you do with it? Easy to think of, right? You'd probably be a little bit confused. And then also, it could be that it's one of these, right? It could be that it's one of these. As it's going down towards you, you have to kind of wonder, and maybe you can assess it, but guess what? Now you figure out it's one of these or maybe something different, and it's too late and it's game over. So what happened here? Well, of course, we can't really do this game if we can't see those shapes and colors. It just doesn't make any sense, right? So Tetris, nice game, been around forever. In 1984, I believe, a Russian developer, if I'm not mistaken, could be wrong, correct me please. Tetris, I would like you to meet schema on read, or some of the common lake architectures or big data or NoSQL or whatever else. And of course, a little smiley face there. We have a huge volume of data arriving at incredibly fast rates, velocity. To make it worse, we're not really sure what it is. It's got a high variety, it could be anything. And you can't be sure that it's correct even because of the veracity, the quality issues. And to make it even a bit tougher to handle, okay, what about the value? Okay, we don't even understand what the value could be. So anyway, the point is that we're getting back to is data needs to be understood before it can be used. So how do we gain understanding of the data before we use it? Well, we relate it to what we understand, to something that we expect to see, and something that has business meaning. That's going to have to be the steps, right? How do we capture that? And how do we relate it to the data that comes in? And this is the fun part. Conceptual and logical modeling is how we would do it. How do we relate it? Ensemble logical modeling using Elm. And by the way, we see Elm now in many of our partners and our companies. We are working with Elm in streaming environments, lake environments, and all that type of thing as registered schemas, whatever, because you need to have some way of unlocking what it is you're working with. And of course, that by design has to be business driven. If it's not business driven, it won't work for you. What does that mean? Well, this is what we've discovered here, is that the physical elements of data modeling are seeing less significance and focus now than they were in the past, because it's become more trivial for two reasons. One, because the technology is able to handle a lot of it for us, and two, because we're just, well, in a way, blowing it off, right? We're just saying, well, let's just throw all data in a bucket. Don't worry about that physical modeling side. In this case, what's critical to understand is that now the logical conceptual modeling becomes even more critical. As a matter of fact, we have to rely on these conceptual model exercises with business, these logical models that can serve as schemas, because we have no other way of interpreting. It's almost like what we've done is we've separated the head from the body. So we just have the body, but to do anything with it, to understand it, you have to have the head somewhere. Whether it's connected or not directly, that model has to exist for you to be able to make sense of what you're working with. So that's where we are. I hope this was, I don't know, fun, interesting for you, but that's Tetris as it relates to big data, as it relates to NoSQL, current architectures, and we hope to see you in another video or class. Take care.